Morning, everyone. I miss you all very much. All right, so today we are doing simplifying algebraic expressions, lesson 4.2. So I'm actually going to go over these three problems with you, walk you through it, talk a little bit about it. That way, hopefully that'll help you moving forward with your assignment today. All right, so we are simplifying expressions by combining like terms, right? So you have to remember that like terms have the same variable part. So for example here, right, 4x and 2x would be like terms. Now you have to remember too, terms are separated by addition or subtraction. So this problem right here would have 1, 2, 3 terms. Where these plus signs are, those are the walls that we build between our terms. All right, so 4x and 2x, those are like terms here, right? They both have the variable x. Okay, it's all addition, we're good to go. So I could always rearrange this, right? Addition is commutative. I can change the order to make it easier for myself. So I have 4x plus 2x plus 6. Right, now I've put my like terms next to each other. Okay, so 4x plus 2x. Well, think about our tiles like we did that Friday before we left. If I have 4 x's and 2 x's, how many am I going to have all together, right? It's really just 4 plus 2 gives me 6x. Now, plus 6, I bring this down. Now, I cannot combine those any further, right? Because this 6 has an x, and this 6 doesn't have a variable. So they have to have the same variable part, right? So that would be my final answer here. All right, moving on to the next one. So I have a problem here, all right? I see like terms, right? I see an m and an m, right? And I see a 3 and a 4. They don't have their variable parts. But my problem is that I see subtraction, right? I always want to rewrite subtraction as adding the opposite. So I would rewrite this, right, as 2m plus 3 plus, what's the opposite of 7m? Negative 7m. Plus, what's the opposite of 4? Negative 4. Right? The reason I do this is so that I can move my terms around. So I can bring my like terms together. And remember, addition is commutative, but if I were to leave it as subtraction, right, subtraction isn't commutative, so I can't change the order. So that's the reason I'm rewriting this as addition, right, is adding the opposite. Okay, so now I can move some things around. These both have a variable of m, so I can combine them, right? So I'm going to move them together. I'm going to bring 2m plus my negative 7m, all right? And then I'm going to put plus 3 plus negative 4. All right, and now I've got some like terms. Now I've got, right, 2m and negative 7m. And I've got 3 and negative 4, right? Probably should have picked colors that looked a little bit more different, huh? Maybe I'll recircle this with blue. There we go. Okay, so now I can work on combining those like terms. So I can think of this, right, as 2 plus negative 7. This is where you gotta remember those rules of integers that I keep telling you are so important. 2 plus negative 7. I'm adding two integers with different signs. So I'm going to subtract their absolute values. So 7 minus 2 is 5. And I'm going to take the sign of the number that's further from 0. So if I look, negative 7 is further from 0, giving me a negative 5m. All right, I can bring my addition sign down. Now I have 3 plus negative 4. Right, 3 plus negative 4. Different signs, subtract their absolute values. 4 minus 3 is 1. And take the sign of the integer that is further from 0, right? So it's going to be negative 4, so I'm going to have a negative 1. All right, we talked before we left about these being next to each other, right? How I change it to adding the opposite, I can even go back. So if I want to change this to subtracting, I would take the opposite of negative 1. So my final simplified answer, sorry, I'm running out of room here, is negative 5m, and it'd be minus, the opposite of negative 1 is positive 1. Oh, this negative 5 is supposed to be in there, sorry. All right, I should start a blooper reel for these videos. All right, good. Last one. Maybe I could, I won't erase it. All right, so let's do this last one. There's a property here that we learned about where you get to be Oprah, you have to share it with everything inside the parentheses, the distributive property. So we have some like terms, right? I see an M here and an M here. This S is by itself, right? Can I combine the S and the M? No, variable parts are not the same, right? But I gotta do something first. I gotta distribute this 4 because it's kind of just out here right now. I gotta distribute it amongst everything inside the parentheses. So that means I need to do 4 times S, right? Multiply. 4 times 8m, multiply. Not 4 times m, though, that's no. It is not inside the parentheses, only what is in these parentheses. Okay, so I'm gonna rewrite that. 4 times S is just gonna be 4s plus 4 times 8m, right? Okay, what's that gonna give me? 32m, good job. All right, plus my m was on the outside. All right, I need to remember that in front of this m is a 1, right? That's 1m. So now I can go about combining my like terms. All right, what do I have here that is alike? Well, s, is there any other term with an s? No, I have 1, 2, 3 terms. Okay, so s by itself can't do anything. But here, notice I have 32m and 1m. They have the same variable part, so I can combine them. All right, so they're already next to each other. I don't need to move anything around. I can keep my 4s because that doesn't have any friends here. It doesn't have any like terms. All right, 32 plus 1, 33m. Right, and there's going to be my final answer for that one. All right, so you're going to be doing problems like this today. Can I turn my thing around? No. Okay, well, all right, good luck. All right, you will do just fine. Okay, I miss you all very much. Have a good day.